All right, let's see if you guys are all paying attention. So class.
Yes.
Thank you. All right, and Denny. There we go. All right, so implicit differentiation is probably one of my favorites to do. It really is, because I don't know, I find it fun. I do, but I enjoy math. And I do not enjoy some type of math. Not all math is fun, but this is fundamental.
No.
Hey, get it? Get it? Okay, good. All right, I tried. All right, implicit differentiation. So what this means is we're taking a derivative and we have multiple variables. Yeah, we're taking a derivative and we have multiple variables that we need to account for. So what I'm going to do here is I'm going to find dy dx, xy minus 4 equals 0. Okay. Now, reading this using Leibniz notation. So the function is which function here? This means it's function y, right? It'd be a y equals, right? So that's what the top part means, the function y. So the derivative of y, and I'm taking the derivative that in terms of the x. So I'm taking the derivative for the x value here. But when we do this, we're actually going to be taking derivatives of variables that are not the x. So by that, I say that this is going to be a product rule. Okay? That's going to be a product rule. So by labeling it, that's an F and that's a G. So F prime, what's the derivative of x? Right? Okay. The next one is G prime. Now, we treat it as if it is my variable. So that's going to be 1, but times, because I am not taking this function here itself is a dy dx, right? So I need to say what I did, because this one wasn't a y. So it's going to be a dy dx. So when I take the derivative of a variable that is not the x, that is not this thing right here, I need to state that I did that, so therefore this was a dy dx. So I could have done the same thing if it was a z. That one would have been a dz dx. If I had a whole bunch of different variables there, I would have labeled it as such. Okay, so let's continue with the product rule. So now, what about that minus 4? What's the derivative of negative 4? 0, right? Negative 4 is a constant, so the derivative of a constant is going to give me 0. So let's go through and do that product rule now. So my product rule is f prime g, so it's going to be 1 times y minus, nope, product rule is a plus sign, sorry, g prime, which is 1 dy dx, g prime f times x. Derivative of that negative 4 is 0, right? Okay, and that all this here, bring it all down, it's going to equal 0. Because the derivative of 0 is 0. Alrighty. So, let's go ahead and kind of put it together. I'm going to rearrange it a bit. So this is going to be y plus x dy dx equals 0. All I'm doing is just multiplying them and rearranging a bit so it's going to be all nice and organized. Okay, so I want to try and get the dy dx by itself. I want to get the dy dx by itself. So that means that this is going to be subtract y to both sides. So I get x dy dx is equal to negative y. And then I need to get rid of that x. What is the x doing to my dy dx? Multiplying, and how do I undo a multiplication? Very good. So I'm going to divide both sides by x. So dy dx is equal to negative y over x. So I was able to isolate my dy dx to get my y by, or not my y by itself, but get my function right there by itself. Okay, so now I'm going to try it again, but this time, okay, we used implicit, so now this time right here, I'm going to solve for y, then take the derivative. So if I'm going to solve for y, start by adding 4, right? X, y is equal to 4, and divide by x. So y equals 4 over x. And then if I were to take the derivative of this, okay, now the notation of this turns into y prime is equal to, what do I do with that thing?
Oh, make it into 4 negative
X to the negative 1, right?
x to the negative 1.
So yeah, that's, okay, so I bring this up, right? So this is going to be 4 times x to the negative 1. And so if this is 4 negative 1 like that, so it's going to give me negative 4, right?
Yeah.
X to the what?
1. Oh, yeah.
Because I have to subtract, don't I?
Yeah, subtract that 1.
Yeah? Okay. All right, so from here, I can rearrange it to make it look a little bit better. So now this is y prime is equal to, that's an equal sign, negative 4 over x squared. Now, notation, like if I were to change that to Leibniz notation, so the y prime is the same as saying dy dx, right? Say yes. Y prime is the same as saying dy dx. Okay, so I'm just going to rewrite it. So dy dx is equal to negative 4 over x squared. Now, I'm going to go back over here, and this one over here says I have dy dx is equal to negative y over x. What's different about this one than my other one? What does this one here have that the one that we just didn't have? A y, right? Does this one have, this one has a y, right?
Yes.
Okay. This one has a y in my answer. So I did not isolate it. This one has a y in the answer. The other one doesn't. Okay, let's see. So I'm going to take this one right here, and by isolating y, what we did earlier, we said that y was equal to negative 4 over, was it x? Negative
Yeah.
4 over x?
Oh, square, x.
No, y.
All against the y, okay.
Y is equal to negative 4 over x, right?
Mhm.
Okay. So just by isolating, I say y is equal to that. Wrong way. Why is it going wrong? There we go. Okay, so y is equal to 4 over x. I'm going to substitute that. I'm going to replace the y in this over here. I'm going to replace this one here with the value that I have there. So by doing that, let's see. It's going to give me, so I'm replacing the y. I have negative 4 over x divided by x, right?
No, there's another negative.
Oh, there's another negative, right? There we go. Like that, right?
Yeah.
Okay. I know 2 negatives is going to do what?
Positive.
It's going to make that to a positive, right? Okay, so it's now going to be positive 4 over x divided by x. So positive 4 over x divided by, and I'm gonna do the denominator. I'm gonna make that over 1, because that's gonna make my multiplication a little bit easier. What's x divided by 1? Isn't that still just x?
Yes.
Okay, that's still just x, but I have fraction over fraction now. Now, if I ever have a fraction over fraction, I multiply by the reciprocal. So this would turn into 4 over x times the reciprocal of the bottom.
1 over x.
1 over x, right? And that's going to give me 4 over x squared.
And that's the positive thing.
Isn't that the same as what I had over here? By isolating it first, I ended up eventually getting the same thing, right? Is this the same as what I had over there? 4 over x squared,
Okay, the same number, because I thought it means the same sign, like, both.
and there it is right there, and
Is negative, and I was like, what's positive?
where am I losing it? Did I lose a negative?
The other answer you have is also negative. Check the one with dy over dx. Because that's negative y over x. And the
Oh, it's a negative y over x. Okay, so that's where I didn't carry it over. So,
y prime was negative 4 over x squared. So there's two negatives, which would make it.
okay, so we get this, right?
Yeah, because the negative 1, because 4 over x is. Are you sure 4 over x doesn't do anything else?
No, every place that we have a y equals, I'll replace it with that. Okay, so I have it
Oh,
there.
no. Oh, okay, I see what it is.
I have it here.
4x positive.
I have it there.
So switch back to the other one.
And this is 4 over x squared, right?
Yeah, that's 4 over x squared. That's y prime. So check the other one.
Plus product divide. That's a negative.
No, Pacho, go back to the idea. Because over there, that's y. Since you're just doing y, it's actually just positive 4x.
Oh, is that what I did?
Yeah. I actually probably told you that.
No, no worries.
But yeah, just erase the parentheses. Because that's actually negative.
Okay, so
There you go. Now it's 6.
No, okay, so I apologize, I hate making mistakes, I really do. Especially since I am recording this, and I never go through and edit my videos.
So that would become a negative.
This one's back to a negative. Back to a negative, back to a negative, and negative right there.
Okay, there we go.
So now they're all the same. Sorry.
Yay.
So every place when you do implicit differentiation, it's possible to get a y value and an x value, and to put them together to make sure that they are the exact same thing, in the implicit differentiation, you would have to find the y value and plug it back in, so you only have variables with x's. So implicit, we could have right here. Is this the implicit? Yes. Implicit, you could have a y value here and an x value in your answer. And then to make sure that it is correct, you would go back and isolate it, isolate your y value, and plug it back in. But other times it's kind of too difficult to do that, because sometimes you're going to get a y and a y squared in the same problem. So you're going to have multiple variables that does not work out very well. So all the other rules still apply, as if we've been doing this the same way, if it is a y or a x. So just like this, we have right here, taking this, the derivative of this is going to be 1 dy dx, and if it was a y squared, I take the derivative of the y, which would be this 2, and then I subtract 1 from my exponent, and then I add my dy dx. Same thing here, if that's a 3, 3 goes here, subtract 1 from my exponent, and then I add the dy dx for this. It is gonna make sense when you start doing this yourself. So this notation implies that dy dx is used when you're taking the derivative that's to be evaluated at a point xy. So this one's going to be important. So that notation is important. Now, I would like to see you people right now take the derivative of this using implicit. You don't have to go back and substitute and justify your answer. Just do the implicit differentiation here, please. Anyone need help getting started? So, the derivative of 3x squared is gonna give me
6x.
6x, very good. Okay, nothing crazy there. Now the derivative of 4y squared. 8, right?
Yeah.
Y, and then when I take the derivative of something that's not the x, I add dy dx.
Oh, you can't do this.
Okay, it's a multiplication, just so you know. It's always a multiplication. Bring down my equals. Equals what? 2. There we go. So we took all the derivatives. And now the next thing that we would do is get the dy dx by itself. Get the dy dx by itself. So, a little bit of algebra. What am I going to do to that 6x? Subtract it. So now I'm going to have, subtract that from both sides, so minus 6x. So I bring down my 8y dy dx is equal to 2 minus 6x. And then again, there's a reason why I keep saying that this is a multiplication. So to undo the 8y, I need to divide both sides by that, right? Because that's a multiplication times the dy dx. And divide both sides by 8y. So I get that dy dx is equal to 2 minus 6x over 8y. The only change I would make to this is, does the top and the bottom have a common factor? Can I reduce it by a factor of 2? There's a common factor of 2, so I can reduce everything by a factor of 2. So by reducing it by a factor of 2, I get 1 minus 3x over 4y. ¿Está muy fácil? Muy. ¿Tú tienes questions? I don't even know how to say question in Spanish. Preguntas? Preguntas. Es mucho pregunta.
Very much question.
Okay. Using implicit differentiation for the equation of a tangent line. Find the equation of a tangent line to the ellipse. What's an ellipse?
An oval.
Yeah, it's an oval. Okay. 3x squared plus 4y squared is equal to 2x at that point to the equation and the tangent line on the same set of coordinate axes. Now, let's go back to what this actually is. What is the derivative actually giving me?
The
Slope of the tangent, right? The derivative is just giving me the slope of the tangent. The derivative is getting me slope of the tangent at a point if I'm given a point. So what could I do with this? I can just plug those in, right?
Yeah.
Okay, so do I already know the derivative? Yeah, because I just did this question last page, right?
Yeah.
So I know that my dy dx is 1 minus,
Wait, isn't it different because it's a 3x thing? Oh, I see that.
yeah, it's the same problem. 3, and I'm replacing x with what?
With 1/2.
1/2
Because it's coordinate.
over 4 times.
Negative 1/4.
So we already did the derivative, and now we're just plugging it in. Now we're just evaluating at a point. So on the bottom, I get -1. On the top, I should get -3/2, but it is a positive 2/2. So here, I'll do my mental math for you. So it's 2/2 minus 3/2. That's a 2.
Okay.
And then minus 1, because those will cancel. So I did common denominator, so that's going to give me -1/2, right?
Yes.
Divided by -1.
Okay.
So -1/2 divided by -1 is going to give me positivo 1/2. Yes?
Yeah.
Okay. All right, so I have the slope, and now what else do I want to have?
Graph the equation.
Yeah, graph the equation. So give me the equation now. What would the equation be?
Standard form
Uh,
or do you want like y equals
give me point slope. That's easiest, right?
point slope? Okay.
That's going to be what?
1 minus plus 1/4. It's already negative.
Okay, plus 1/4. Very good. Equals?
Positive 1/2 on the x minus 1/2.
Very good. And then we're going to have to graph all this, so let's go ahead and take out those calculators. Now, so these calculators are super smart. They're a lot smarter than most calculators you probably have used before. So what we're going to do is, I am going to backspace, start with backspace and change it to a relation. So whenever I have relations, I could actually draw circles and all these other great things. So my first relation that I had was, what's that, 3x squared, right, Jenny? 3x squared
Plus 4y squared.
Huh? Backspace.
Oh, backspace. Okay.
Backspace, and then,
Is backspace the same as delete?
yeah.
Okay. Oh no, never mind. Which button is backspace you're looking at?
Delete?
That one.
Yeah.
Which option do you want?
And you wanted what? Option 6, which is relation.
Oh my gosh.
All right. Anyone need help getting this far? Still, yeah. Not all of them work. I know. I'm having a problem with it because I haven't changed all the batteries on all these. And some of them, it doesn't charge in the charging dock. All right. Questions so far? Anyone need help getting this far?
There you go.
Okay. Alright, so one more, so all you have to do is hit space right there. And here, we're not doing a function, we are doing a relation. We enter our there we go, 3x squared. It's also 0. Yep. Equal sign. Yeah. Pretty small, right? Yeah. So, a couple of ways that we could zoom in on this. You could either grab the axis, you could grab it. Yeah, let's move that. The axis here. And stretch it. And then we could also do menu and window. Anyone else need help? So a couple ways that you could actually do that is kind of like how I did with grabbing the axis and stretching it. Or you could just do menu, window. You can just go zoom in. There you go. That's one way of doing it. Now, we're going to put our second line on there. So I'm going to hit tab. So to put my second line, I hit tab, and it's going to open my other relation, which it was y, was it plus, right?
Y plus.
Okay, so now to do the fraction, you do control, divide will give me my fraction. There's my 1 over 4.
Would the slash work too, or no?
It will, but it makes it nice and pretty if you have, and it clearly identifies what's on top and what's on bottom. When we do some of this stuff, crazy stuff later on, and you have multiple things on top and multiple things on bottom, that you really want to see what goes where.
Okay.
Equals my control divide, right? Because I want my fraction again. I want my 1/2, open parentheses, right? And x minus control divide again. And was that just, it was 1/2, wasn't it?
Mm-hmm.
Okay. So again, these calculators are super smart. You could put it in any format and it will graph it for you. So there it is. It is touching it at this point right here. All right, so now what I did is I went to menu, analyze graph, and I did intersection. And so right here, it gave me the point of the intersection, which is going to be 0.5. Because the approximation thing, it actually tries to throw it way down here. If you see something like this, yeah, my answer is just 0.5. So that's 1/2 here, a positive 1/2, minus negative, negative 0.25, which is my negative 1/4, right? Just as decimals, there it is. So if you notice, whenever you have ellipse, could I also have had another point up here if I was only given one x value? Because this ellipse is not a function, it's a relation. It is an oval. That means that right here where x is 1/2, isn't x also 1/2 up here? So whenever you're dealing with ellipses, circles, ovals, all these things, yeah, when you graph it and you look at it, there is multiple answers that you could have. All right.
So it's almost like a circle, almost.
Almost. It's just if
If they narrow it, probably, or?
yeah, it's slightly it's small values too. We have the difference between 3 and 4 in between my x and y, so that it's really not much. Anyway, that being said, so we were able to graph it and put them both on the same thing to see where it is. We were able to plot our axes, and then from there, I'm gonna pause right here, and I want you guys to start working on some of these problems in the homework. So I'll go over question 15 from the homework, because that one's a good question, and I'm actually recording it too, so there it is. Okay, so 15. Oh, dang it. There you go. Okay, right here, 15. So read it to me for me, please. Yeah.
Okay. X squared minus y squared minus xy equals 2.
Okay, so this is a good one. It's actually got a couple different things, and it has a product rule in here. So let's go ahead, item by item. This is going to give me 2x minus 2y, and I'm taking the derivative of something that's not x, so that's going to be my dy dx minus, now over here, that's a product rule. So that's a product rule. So let's see. So f prime. So if this is f and g, f prime is going to be 1. G prime is going to be, that's a G, not a 5, just so you know. Okay, so that's a G. So G prime is going to be 1 dy dx. And so I'm going to plug that into my product rule right here where my parentheses is. So f prime is 1, f prime g, so it's going to be 1 times g, which is y, plus sign, g prime f, so g prime f is going to be my 1 dy dx times g, which is, oh, I'm sorry, f, which is x. Right there. Bring down my equal sign, and the derivative of 2 is just going to give me 0. So the parentheses out front of all this is super important. So don't lose that parentheses, because that minus sign needs to be distributed to the whole thing. So as I rewrite this, I'm going to bring it down. So I had 2x minus 2y dy dx. And as I distribute this, this is going to become a minus y. And as I distribute this over here, that's going to be a minus x dy dx equals 0. All right. Anyone questions of what I did there? Super crazy? Now, my whole goal is to get my dy dx by itself. So let's get rid of the other things that are not dy dx. So the things that are not dy dx's are my 2x and my negative y. So I'm going to subtract 2x, and I'm going to add y. So minus 2x, and then plus y. So now I'm going to be left with negative 2y dy dx minus x dy dx equals negative 2x plus y. Now, this is the point that I keep emphasizing, that it is a multiplication. The dy dx is being multiplied. And so both of these on the left-hand side, they have a common multiple of dy dx. So I'm going to factor out the dy dx, so that's going to come out in front. Dy dx, parentheses, after I factor that out, I get a negative 2y. Bring down my negative x equals my negative 2x plus y. And then, to get my dy dx by itself, I'm going to divide both sides, right? I'm going to divide both sides by the quantity of negative 2y minus x. Is that the right answer? Are you checking it?
I was also checking the other one. X minus y over 2y plus x.
Their signs are different because they left a negative inside there.
Yeah.
Negative 2y minus x, right? So what they did, they factor out the negative there and distribute it on the top, so that would make it a negative y
Yeah.
and a positive 2x on top.
Yeah.
Yeah, there we go. So that was a good question. So I wanted to make sure you guys actually see where everything comes from. And this was a good one. It was the first opportunity where you have to factor out your dy dx to get that by itself.
Yeah, do 19.
You do 19.
I am doing that.
Keep doing it. All right, I'm going to pause this one again. All right, so we're going to continue the notes here. So we're starting this one right here. So y prime is the same as saying dy dx. I don't like using the y prime notation because you could easily mistake the y prime for a y to the first, right? You don't, it's kind of a pain, especially when you get the problems that are going to be a little bit longer, more complicated. It's easy to lose a y prime versus in your equation having a dy dx. But we're going to do this one using y prime. So e to the y cosine x. So e to the y times cosine x equals x plus 1. So over here on the left-hand side, I have a, what rule is this? Product, right? That's a product. It's a multiplication. So I have a product rule. So that means that this, so my f prime, what's the derivative of e to the x? E to the x. So the derivative of e to the y would be e to the y dy dx, right? So, but this one, instead of doing dy dx, we're just going to call it y prime. So it means the same thing. I want to show you both, but my preference is the Leibniz notation of dy dx. So this is going to be e to the y, y prime. G prime. Derivative of cosine x is going to give me, perfect, negative sine x. All right, so let's go through. So it's going to be f prime g. So that's going to give me e to the y, y prime, f prime g, okay, times cosine of x plus g prime, negative sine x times f, which is e to the y. Bring down my equals. Derivative of x is 1. Derivative of that 1 is 0. All right, so now in this case right here, I'm trying to get the y prime by itself. I want to isolate to get the y prime. So I'm going to clean up my math. I'm going to clean it up so it looks a little bit easier on the eyes. So this is going to become e to the y cosine of x times y prime. So I just reorganize that. And this next one over here is going to become a minus sign, minus e to the y times the sine of x equals 1. Now, again, this is kind of why I prefer the Leibniz notation, the dy dx, because I'm trying to get the y prime by itself in this case here. So I'm going to start by moving over that over there. So I'm going to have to add e to the y sine x to both sides. So by adding it to both sides, I have e to the y cosine x y prime equals 1 plus e to the y sine of x. And again, I'm trying to get the y prime by itself. So what am I going to do to get the y prime by itself here? Divide both sides by e to the y cosine x. So y prime is equal to 1 plus e to the y sine x over e to the y cosine x. So depending on your penmanship, you could actually look back at this problem and clearly see how a y prime could get lost in all of this. All right. Questions, concerns, complaints, conspiracy theories? No conspiracy theories either? So we're going to continue this on, when I see you guys? Friday, we're going to do the higher orders. All right, make sure you all like, share, and subscribe. Hit that notification button, support my channel.